Welcome back from the ad break, and let's continue with our lesson. The next concept that we are going to be focusing on is comparing a rectangle and a parallelogram. So remember, we said that a rectangle is a special parallelogram, but what are the differences between these two quadrilaterals when it comes to their sides and their angles? So let's first look at these sides. So we know that the opposite sides of a rectangle are parallel. So a rectangle has two opposite sides that are parallel. Now this is also true with a parallelogram. Of course, remember, a rectangle is a special parallelogram, which means that all the properties that a parallelogram has, a rectangle will also have. So let's also look at the sides of a parallelogram in terms of their length. So we know that the opposite sides of a parallelogram are equal. That means that AB is equals to DC. It also means that AD is equals to BC. Now, of course, this is also true with a rectangle. So we will see there that PQ is equals to SR and PS is equals to QR. So that's everything in terms of the sides. What about the angles? Now with a parallelogram, we know that the opposite angles are equal. So angle D and angle B, they are equal. This also applies to angle A and angle C. Because they are opposite angles, they are also equal. Now this is the same for our rectangle. We know that the opposite angles are equal. So angle P will be equals to angle R, and angle S will be equals to angle Q. But now what makes a rectangle special is that all of the angles are actually equal. Not just the opposite angles, but all of them. And not only do we know that they are all equal, we also know that they are all equals to 90 degrees. So all of the angles or the interior angles of a rectangle are equals to 90 degrees. So that is where a rectangle and a parallelogram differ, because with a rectangle, we know that the angles are equals to 90 degrees. What about the diagonals? Now, when it comes to the diagonals of a parallelogram, we know that they bisect each other. So there where they meet at T, we know that DT will be equals to BT. And we know that AT will be equals to CT. So that is absolutely true with a rectangle as well. Now, what makes a rectangle special is that the diagonals of a rectangle, not only do they bisect each other, but they themselves are equal as well. So that means that PR is equals to SQ. So those diagonals themselves are equal. So yes, they do bisect each other just like a parallelogram, but they are also equal. Let's look at the following question. It says there, the following parallelogram is given. Calculate the values of X, Y, and Z. So we already know that it is a parallelogram. So that means that we should be thinking of the properties of a parallelogram. So let's look at X first. Now we can see where X is. And we know that because this is a parallelogram, that means that we have two opposite sides that are parallel. Now, we have been given 137 degrees as one of the angles there. And because of the parallel lines, we can see that the given angle with the X that we are looking for, they form co-interior angles. Now, this means that X plus 137 degrees, they are equals to 180 degrees. And the reason for this is the co-interior angles and that AB is parallel to DC. Now, using the additive inverse of 137, then we can say that X is equals to 180 minus 137 degrees. That means that our X is equals to a 43 degrees. So our X here is equals to a 43 degrees. What about our y? So when we are looking at y, we can see that y is opposite our 43 degrees that we just calculated there. So because this is a parallelogram, that means that y is also equals to 43 degrees, and the reason for that is because they are opposite angles of a parallelogram. Then we have our z, so our y there is 43 degrees. Then we have our z, and our z is opposite the given 137 degrees, which means that it is also 137 degrees. So our z is equals to 137 degrees, and the reason for that is that they are opposite angles of a parallelogram. So that is how we would have calculated those angles there. But what about if this parallelogram was a special one, namely a rectangle? Now, if this question was exactly the same, but we were given a rectangle, then we could have calculated these angles much faster and much easier. Now, how do we know that that is a rectangle? We know that it is a rectangle because one of the given angles is a 90-degree angle. So we have told that it is a parallelogram, and we are given one of the angles as a 90 degrees. This would simply mean that x is equals to 90 degrees, y is equals to 90 degrees, and of course z is also equals to 90 degrees, simply because we know that this is a rectangle. Let's look at the last concept in our concept map, and that is a square and a rhombus. Now, if you remember, a square is a special rectangle and a rhombus is a special parallelogram. So that would mean that all of the properties that apply for a rectangle will apply in a square, and of course all the properties that apply in a parallelogram would apply in a rhombus as well. So when it comes to the sides and the angles, with a rectangle and a parallelogram, we saw that all the properties were the same. The only difference was those angles. So when it comes to the side, with a rhombus, all of the sides are equal. With a square, all of the sides are equal. When it comes to the two pairs of opposite sides, yes, two pairs of opposite sides are parallel to each other. Parallel to each other with a square, and also parallel to each other with a rhombus as well. So the sides, the properties of the sides are the same. When it comes to the angles, the opposite angles are equal. But with a square, yes, the opposite sides are equal, but they are all equals to 90 degrees. Remember, a square is a special a rectangle. So all of the angles there are equals to 90 degrees. So the main difference between a rhombus and a square is that the angles, yes, the opposite angles are equal, but with a square, those angles we know are 90 degrees. What about the diagonals? When it comes to the diagonals, we know that the diagonals of a rhombus, they meet at 90 degrees. And of course, that is the same with our square as well. They do meet at 90 degrees. We also know that the diagonals, they bisect the opposite angles. So KM does bisect angle K and angle M, as well as NL does bisect angle N and angle L. Now, the true is said with a square as well, because we can say that SQ bisects angle S and angle Q, as well as PR bisects angle P and angle R. But what is different about the diagonals of a rhombus as compared to the diagonals of a square? Well, the diagonals of a square are equal. So that means that SQ is equal to PR. So those diagonals are equal, and that is the main difference between a rhombus and a square when it comes to the diagonals. So even though these two shapes or these two quadrilaterals, they may look similar or have similar properties, they are not the same, as we have seen there, comparing the sides, the angles, and the diagonals. So with the two last concepts of our lesson, we saw that the rectangle and the parallelogram, they have a similar properties, but they are not the same. Now, this is also true with the square and the rhombus. They have similar properties, but they are not the same. Thank you for joining us for this wonderful lesson. I really enjoyed it, and I hope you did too. Hope to see you next time. Goodbye.